Hi dear students, good morning. Today we will be having an in-text question discussion for the chapter effects of electric current. Already we had one doubt clearing session and we also have completed the entire chapter. But I feel many of the students are having difficulty to answer the in-text question, especially for those questions where a substitution for some sort of equations are required. So I will try to answer out all those questions starting from the first page of the chapter till the last. Okay, in between, if you have any doubt, you can ask it then and there itself. So the first few pages we are having simple question, though I tend to answer that also because maybe someone else will be having difficulty to answer that too. So let us start answering the questions from the first page onwards. On the first page, there is a simple task to fill those spaces left with the equipments that are seen in that picture. Already electric bulb and electric fan are given there, so the rest can be mixie, induction cooker, microwave oven, storage batten, inverter and all. Right, you can see there it in the picture itself. Now let us see page number 8. There you can see a table 1.1. It is provided with the name of some devices, and just for an example, for one of the device, its use and energy change is given. For the rest, we have to fill it with its use and the energy change. And some space are left under the column for device. There you can write some devices of your choice and you can write its use and energy change. So here, for an electric bulb, its use is to get light, right? For electric bulb, its use is to get light. Now what is the energy change taking place there? The energy which we provide to an electric bulb is electrical energy. So you write electrical energy, then it is converted into light energy. It is converted into light energy. You know that when an incandescent bulb or filament lamp is working, along with light energy, some amount of heat will be also found that we are not mentioning here. Now the second one, it is already filled with the use and energy change. In an induction cooker, its use is to get heat and its energy change is electrical energy to heat energy. Okay, no problem. Now for the third one, storage battery, and is specially given while charging. So its use is to store electricity, right? To store electricity or to store current. To store current. And what is the energy change there? The energy change is electrical energy. Let me write as short in EE. Okay, electrical energy into what energy? Chemical energy. Okay, electrical energy into chemical energy. So some sort of chemicals are inside this storage battery. While we use it for charging, it stores current by converting the electrical energy into chemical energy. Now in the case of mixie, what is its purpose? For a mixie, it is used to grind things, right? It is used to grind. So you can write for grinding. Now what is the energy change there? It is electrical energy into mechanical energy. You should keep in mind that you have already studied regarding mechanical energy in your class 6, right? Energy is associated with the movement of machine. That is usually called as mechanical energy or commonly called as mechanical energy. And here in mixie also, it is used for grinding, and there the electrical energy is converted into mechanical energy. Now you can fill two other devices. For example, let me fill it with the electric fan. Now what is its use? What is its purpose? To get breeze, right? To get breeze. Not wind or storm, right? To get breeze. And what is the conversion there? We are providing electrical energy to this electric fan and it is converted into mechanical energy. It is a machine, therefore the energy is converted to mechanical energy and this will provide us with the breeze. Now there is a promise to write one more example there. What should I write? Let me write microwave oven. Just as we saw in the last picture, we can fill here with an example of microwave oven. Then use is to get heat, right? Oven is used to get heat or to cook things. Now what is the conversion? Electrical energy into what energy? Heat energy, right? Electrical energy into heat energy. So by this we have filled the table 1.1, and I think now it is clear for you what to do with such tables and all. Now there is another question given. Which are the devices that give heating effect of electric current? What all things give you heat while electricity is given as an input? So we know that an iron box, that is electric iron, then electric stove, then microwave oven, just as we wrote now in that table, microwave oven, heating coil, and induction cooker are some examples for devices which uses electrical energy and convert it into heat energy. So this is the same question in that page itself. Under the topic heating effect of electric current, you can see that question. Now let us move to the next page, page number 9. There you can see a figure 1.1, and that figure you can see a Necron wire of some resistance R is connected to 6 volt battery via switch. Right. Now the first question given below that, how does the Necron wire become red hot while passing electricity through the circuit? Before discussing or before going to the question, you should know that this Necron wire is having high resistance. Usually for all those heating purposes, or if we are in requirement of a heating coil, we uses this material called as Necron. Okay. This is an alloy. Necron is an alloy, and the speciality of Necron is that its resistance value is too high. You should know this, okay? You should keep this in mind, and let us try to answer those questions. How does the Necron wire become red hot while passing electricity through the circuit? Now, whenever electricity is passed through the circuit, this Necron wire becomes red hot. Now, the question is, how is that possible? It is possible due to high resistance for Necron wire. As I told you, Necron is an alloy and it is having high value for resistance. And due to this, the energy that we have provided Necron wire, or that is in the input of the circuit, is converted into heat energy. Okay. Now the second question is, in this case, which form of energy was converted to heat energy? So what was the energy change there? We know that electrical energy that we provided in the circuit was converted into heat energy. So which form of energy was converted? Electrical energy is converted into heat energy, right? Electrical energy is converted into heat energy. Now what is the third question? How does this energy change occur? So we know the energy change is from electrical energy to heat energy. Then how does it occur? So we have to write like Necron is having higher resistance, right? So write like Necron is an alloy with high resistance. Okay. Therefore, the energy of electrons get lost in the form of heat. So what was that? Necron is an alloy with high resistance. Therefore, the energy of electrons get lost in the form of heat. You should keep this in mind, that as the resistance is more for Necron, electrons will find really difficult to pass through the Necron wire. So the energy associated with them, it will be lost or dissipated in the form of heat, which is the reason behind this energy change. Okay, and it also you can write it also follows what? Conservation of energy, law of conservation of energy. You can add that sentence also. this follows law of conservation of energy. Okay, so we have completed that answer also. Now let us see the other question in the same page, that is the figure 1.2. There you can see one question, that is to write the value of charge and all. Equation is already provided there. So let us read that question. If the ammeter shows a current I ampere on applying a potential difference V across the resistor of resistance R ohm, then current I is equal to Q by T. I think that equation is already familiar for you. So it is given there I is equal to Q by T. Current is equal to charge by time. Actually, the definition of current itself is that it is the rate of flow of charges through a conductor. Rate of flow of charges through a conductor. So we can write, or we can represent I as I equal to Q divided by T, charge per time. Then the charge that flows through the conductor in T second. So in T second, how many charge flows through the conductor? I told you, consider a conductor. If Q amount of charge or Q charge is flowing through that conductor for T second, then I is equal to Q by T. Then what is the Q there? You take this T to left hand side. You will get I into T is equal to Q. That is the answer. Okay. We are not provided any numbers and all there. We have to write the answer in general. So you can write I into T is equal to Q. This is the simplified form, sorry, not simplified, rearranged form of this equation. Okay, we have rearranged this equation to this one so that we get an equation for Q. Now let us see the other question. Question number 6. Factors influencing the heat developed when a current passes through a conductor. What are the factors which influences the heat developed in a conductor? So what are those factors? We have studied this under the topic Joule's law, and from there we know that the heat generated in a conductor H, it is proportional to the square of the current, it is proportional to resistance of the material, it is proportional to the time of flow of current through the conductor. So simply we can write the heat generated is proportional, or the factors influencing the heat can be electric current, then resistance of the conductor, resistance of the conductor, then time of flow of current, So that is it. Now we have studied H proportional to I square, H proportional to R, and H proportional to T in Joule's law. But here the question is simply, what are the factors influencing the heat developed when a current passes through a conductor? So you can write this one: heat, electric current, resistance, and the time of flow of current. Now it represent in this way. Okay, you can write this if you are mentioning regarding Joule's law or something, or else you simply write these three factors. Now I think that is clear for you. Let us move to the question in page number 11. There you can see another table, that is table 1.2, and you need to fill that table. With some general terms I, R and T, so as to find out the heat produced and to compare it with the initial heat which was generated there. So initially it is given that there was I current and the resistance of material is R and the time of flow was T. Therefore the heat generated was equal to H is equal to I square R T. Now we are provided with some other values of I, R and T, so that we should find the value of H, and then we have to compare that H or that heat energy, the value of that heat energy, with the initial one, so that we can say it is twice or quadrupled, or if it is quartered or something. Okay, so let us try to fill that table. You look here, and if you have any doubt, you ask. Okay, so first of all, the value of resistance for the conductor is given as 2R under first column, and current is I itself, and the time of flow is T. Therefore, we can write H is equal to, instead of I here it is I itself, no change. Instead of R here there is another change, that is here we have 2R, so I square into 2R into T. Okay, T is T itself, no change. Therefore the equation will be now 2I square RT. Now compare it with the initial heat you had. First we have H is equal to I square RT. Now we have H is equal to 2I square RT. So the heat that generated now is twice that of the first one. Therefore, the change in heat should be represented as twice. Right? Twice. How I got that? You just divide these two. Simply by observation you can write it as twice, and if somebody have doubt you just divide this heat generated now with the initial value 2I square RT. The heat generated now is 2I square RT. Initially it was I square RT. Cancel these both, you get 2. So the heat generated now is twice that of the initial value. Is that clear? Likewise we have to complete each one of this table with the different values of R, I or T. Okay, let us check the other one. Here it is given that R is the same. Okay, for R there is no change. Resistance is R itself, but I now changed to 2I and T remains the same. So H will be equal to, H is equal to, instead of I we have to put 2I, right? 2I the whole square into, for R it is R itself, R, and for T it is T itself, into T. Now 2I the whole square will give 4I square RT. Now we have to compare it with the initial value. Initially we had I square RT, right? So 4I square RT divided by I square RT. We can cancel these similar terms and you will get 4. So heat increased 4 times. You can write 4 times. In the last column you can write 4 times. Change in heat is 4 times. Now let us move on to the next one. Now here R has been changed to half its initial value. That is, we are having, instead of R by 2 now. So instead of R by 2. Instead of I itself, no change for I and no change for T. Then the heat generated H is equal to I square into, instead of R we have to put R by 2 into T. Therefore the equation will be now I square RT by 2. Initially it was I square RT. Let us compare the heat generated now with what we had first. So it will be I square RT by 2 divided by I square RT, which shows the answer is 1 by 2. So the heat or the change in heat is now half. Heat have been changed to half its initial value. So change in heat should be written as half. Okay. Now let us see the other question or other one of this table. What was that? For instead of R itself. So R remains the same. R remains the same. I change it to half its initial value and T remains the same. So instead of H is equal to I square T, now we have to put H is equal to I by 2 the whole square into R into T. That is I square by 4 into R into T, or you can simply write as I square into R into T by 4. When we compare that with the initial value I square RT, I square RT by 4 divided by I square RT, you can cancel these both and you will get the answer as 1 by 4. So the heat change or the change in heat is now quarter, or you can write 1 by 4 times. Okay, quarter or 1 by 4. Now let us answer the next one. Here what we can see is that R remains the same and I also remain the same, but T now doubled, twice that of the initial value, 2T. So now the heat generated H is equal to I square R, and instead of T you have to put 2T. So in the simplified form we can write 2I square RT. And if you compare with the initial value, you will write 2I square RT by I square RT. You have to write like this. If you cancel these both, you will get the answer as 2, which means heat is twice that of the initial value. Twice means 2 times that of the initial value. Now the last one, instead of R, okay, there is no change for R. Instead of R itself, and I remains the same, and instead of T we have T by 2. Therefore H will be equal to I square R into T by 2, or you can write I square RT by 2. Now if we compare this with the initial value, that is I square RT, we will get it is changed to half its initial value. Heat energy produced now is half its initial value. This is the way by which you have to answer this table. I think many of you have difficulty in answering this table, and I think it is cleared by now. Okay, if you have any doubt again, you can ask. So let me move on to the next question, that is question number 8. Analyze the table and find out the factor that influences heat the most. Now we have answered, or we have completed the table, and check the table. For which of the quantities change? The change in which quantity alters or changes the heat energy most? We know that three factors are influencing heat energy. First one is current, second one is resistance, and third one is time. Analyze the table and find out which one affect the heat generated the most. You can see that is current. Let us do one example here in order to make it clear. Consider initially the current flowing through conductor as I, and the resistance as R, and the time of flow as T. Then the heat generated will be I square RT. Now let us double the value of I, R and T one after the other. So in the first case, let me double I. You will get H is equal to 2I the whole square into R into T. That is 4I square RT. So first case is over. Take second case as R I have twice. So R is twice. So H is equal to I square into 2R into T. You will get the answer as 2I square RT. Now the third case, T is twice. H is equal to I square RT, and instead of T you have to put 2T, right? So let me change it. I square into R into 2T. The answer will be 2I square RT. Now look here. Instead of I took 2I in the first case and I got 4I square RT. Second case, instead of R, I took 2R and I got 2I square RT. And in third case also, I changed T to twice its initial value, and again the answer was 2I square RT. From this we can see that the change in I makes change in heat energy to the most extreme value, either to the lowest value or the highest value. The change in I is reflected in the heat energy's equation the most. So which factor influences the heat most? That is intensity of current. Intensity of current. This is the answer, I. Now we will move on to the next question on the same page itself. Actually it is an experiment, but it is quite important, so we will discuss it here. You can see two tumblers or beakers, okay, filled with water. And in the first tumbler A or tumbler beaker A, we have kept a wire PQ, and the second beaker B, we have kept a wire RS. Now you have to go through the question and let me try to answer it. I hope you have already tried your best to answer, and if you are finding difficulty or you want to check your answer, you can hear this part of our video. Okay. Of the water in beakers A and B, which one got heated more? Why? You have two beakers A and B, and the question is, in which beaker more heat will be generated? As we know, Necron has high resistance, right? So heat energy produced will be more there. As the temperature of water will be more in the beaker containing Necron. Is that clear for you? Should I read the question? You listen here. A and B are two beakers of 200 ml capacity. Each beaker contains 100 ml of water. PQ is a Necron wire. PQ is the wire kept in beaker A. And as I told you, that wire is having higher resistance. And you should keep in your mind that if two wires are connected in series, the one with higher resistance produces more heat. Okay, do not forget this. If two wires are connected in series, the one with higher resistance produces maximum heat energy. If two wires are connected in parallel, the one with lower resistance produces more heat energy. Here from the picture, from the figure, one thing is clear. It is a circuit which is in series. Therefore, the one with higher resistance will be producing more heat energy. And as the question says us, PQ is a Necron wire and RS is a copper wire. Therefore, the beaker containing PQ, that is beaker A, will be producing more heat energy, or the water in beaker A will be heated more. Okay, so the answer for that question is beaker A is water, or you can write water in beaker A. Water in beaker, let me rub this part. Yeah, water in beaker A. Water in beaker A. Beaker A gets heated more than that in beaker B. And why? Second part of the question is why? Because Necron has high resistance and hence, no need of this comma, and hence more heat energy will be produced according to Joule's heating effect. Joule's heating effect. In bracket you can write H is equal to I square RT if at all required. H is equal to I square RT. Now the second question is, what change is observed in the temperature of water in both the beakers when the current is increased using the rheostat? You can see some symbol like RS there. It is actually rheostat. So using a rheostat you can increase the amount of current. And we know that if the current is increased, and in this case it won't be just for beaker A or beaker B. If you increase the current, it will be increased in both A and B. Therefore, if current is increased, according to the equation H is equal to I square RT, heat produced will be also increasing. So you write like heat produced, second answer for second question. Heat produced increases if we increase the current. Third question, what was the change that happened to the temperature of water in both the beakers on increasing time? They are just analyzing this equation, and they are just asking you regarding each of the variable in this equation. So if we increase current, heat energy will increase. If you increase resistance, heat energy will increase. If you increase time of flow of current, then also heat energy will increase. So again, the answer is temperature is increased if time of flow of current, time of flow of current is increased. I hope it is clear for you. Okay, now we'll move on to the page number 12. There some problems are given. Let me analyze question number 10. That is the first question in that page. Heat generated is equal to 2400 joule. It is given that the heat generated is 2400 joule, right? So let me write H is equal to 2400 joule. Now, what the question demand is to write the answer in calorie. That is very easy, because you know that 4.2 joule is equal to 1 calorie. Now the answer is in joule. So you have to divide it with 4.2 in order to find the answer in calorie, or in order to convert that answer into calorie. So write like 2400 divided by 4.2, that is equal to 571.42 calorie. Okay, that is it. That is so simple. 571.42, 571.442. Okay, that is not a great question, or that a lot of attention is not required for such a question. Just need to know the conversion. Now let us check the 11th question. What is the 11th question? Let us find out the heat developed in 3 minutes by a device of resistance 920 ohm working under 230 volt. You can see that question is already answered in textbook using the equation V square by R into T. Now what textbook demand us is to do the same question using another equation, that is H is equal to I square RT, and to find the answer and to compare whether these two answers are same or not. So if you substitute the value of I, R and T, you will get the answer. First of all, we need to find I. We know that I is equal to V by R from the equation of Ohm's law. And we have V is equal to 230 and R is equal to 920. The answer will be 0.25 ampere. You need to substitute that here. So that will be 0.25 the whole square into 920 into the time of flow. Time of flow is given as 3 minutes. So we need to convert it into seconds, right? 3 into 60. 3 minutes. We have to convert it into 60 seconds. So 3 into 60, that is 180 seconds. 920 into 180. The answer is 10350 joule. That is already we have got that answer, or already textbook have done that question with using another equation, and they have got the answer as 10,350, and here also we got the same answer. Okay, so the answer coincides, and we have find out the answer to be similar in both cases, or when we use both of these equations we are getting the same answer. Now what else in this page? Is there any difference in the amount of heat energy that's obtained? No. The heat energy we found out using both these equations are similar. That won't change. Not just these two equations. You know that for heat energy generated, we can use three equations. H is equal to I square RT, or H is equal to VIT, or H is equal to V square by R into T. Using these three equations, you will get the same answer. You can, if you need, you can do the same problem with this equation also, and you can find out that the answer remains the same. Now we will move to the page number 13. How this problem can be solved using the relation H is equal to VIT. That is, we are going to use this equation, that is H is equal to VIT, to find out the answer. Now from the question, we need to find the value of I, and already we have found out that I is equal to 0.25 ampere. So if you substitute in this equation, H is equal to, instead of V you have to put 230, instead of I you have to put 0.25, and instead of T you need to convert this 3 minutes into second, 3 into 60. Again the answer is 10,350 joule. Now also the answer remains the same. Therefore we found out that whether we use the first equation, second equation or the third equation, we will get the same answer. The thing is that we need to first of all read the question carefully, and we need to know the variables which are provided in the question, and according to that we have to choose the equation. No need to find out the answer using these three equations all the time. You just need to take any one of these equations depending upon the question, substitute the values and find out the answer. That is it. Now what else are there in that page? Page number 12, right? Yeah, it is almost over, and in page number 13 we have done the first question. Now let us see the second question in that page. Let us calculate the heat developed when 3 ampere current flows through an electric iron box designed to work under 230 volt. So the question is, you need to find out the heat developed. Okay, I need to mention one thing here. Always it won't be like this. The question won't be like this. At times it may be shown like the heat energy released, heat energy dissipated, or energy formed, like that. So no need to confuse whether energy or heat energy, it is the same. So now you need to find out the heat energy developed if 3 ampere of current flows through electric iron box which is designed to work under 230 volt. You are provided with the voltage, the current, and what about time? Let us calculate the heat developed when 3 ampere current flows through an electric iron box designed to work under 230 volt. If you read that question carefully, or even for someone with a glimpse of that question, you will be confused. You are provided with I, you are provided with V, and they are asking us which equation will help us to solve the problem easily. Let me tell you, no equation is going to help you out because they have not provided us with t. Whether you are using the equation VAT or you are using the equation I square RT or even V square by R into T, you require T in order to find out the heat. So without time, we will be unable to solve this problem. Okay. So in some other textbook, we can see that the time is mentioned as 30 minutes. If it is so, let me say you add this in a textbook also. Take t is equal to 30 minutes. Let the time be 30 minutes or half an hour. Then let us try to solve the problem. V I and T is given. So this will be the equation that we need to use. So to find the heat generated easily. You can use the other equations also. Then you will need to find out R by using the equation V by I and all. So no need to do all those stuff. You just substitute the value of V, I and T in this equation. H is equal to V, I, T. Instead of V, you need to substitute 230. Instead of I, you need to substitute 3. Instead of T, one thing you had noticed that here T is provided in minute. Right, the unit is minute. You need to convert it into second. So 30 minute is equal to 30 into 60 second, that is 1800 second. So that will be equal to, here we can substitute that. So that will be equal to 30 into 3 into 1800, and the answer will be, what will the answer? 230 into 3 into 1800. The answer will be 1,24,000. Sorry, not 1 lakh. 12,42,000. 12,42,000 joule. Or if you divide it with 1000, you can show the same answer in kilojoule also. 1242 kilojoule. 1242 kilojoules. Okay, so you need to convert that time which is given in minute into second if that is the case. Actually, in this question in our textbook, the time is not provided, and without time, you using any of these three equations, you won't be able to find the answer. Not just easily, you won't be able to do the question. So we have took time as 30 minutes and we have tried to do that question, and we got the answer as 12,42,000 joule or 1242 kilojoule. How I converted joule to kilojoule? Divide by 1000. Okay, divide by 1000. That is the way. So here we found out that such questions are not a difficult task. Just with careful observation of the question and by substituting the correct values, we will be able to get the answer easily. Now another question is given in the same page, that is in the form of a table, table 1.3. Let us check that question also. Here in the first column, it is shown as heater A, and for that working voltage is 230 volt. Then resistance of that heater is 1150 ohm, and it was for 5 minutes. 5 minutes. And for the second heater, heater B, its working voltage is 230, it is the same, 230 volt, but its resistance is somewhat low, only 460 ohm, and working time is 5 minutes. Time remains the same. One thing is obvious, as here the value of resistance is low and here the value of resistance is high, some changes might be there in the value of heat generated, right? So with these three variables V, R and T, we can find out H using the equation V square by R into T. In either side you can apply this equation and find out the answer. So in the first column, if you substitute this equation with the values, it will be equal to 230 square by 1150 into 5 minutes. You have to convert it into second, that is 5 into 60, that is equal to 300 second into 300. In second column, or for heater B, the only change is in the value of resistance. If you substitute that as shown in the textbook, the answer will be 13,800 joule. 13,800 joule for the first heater and 34,500 joule for the second heater. Now, why does the heater having low resistance get heated more? Before some one or two question, I mentioned you in parallel circuit, the one with lower resistance produces more heat. I will try to explain you this. While we were trying to analyze various factors which influence the heat energy produced, I told you I is having more significance than R and T. This is because in the equation for heat energy generated, it is proportional to the square of I and to power 1 for R and T. That is, it is directly proportional to resistance and time. In the case of I, it is directly proportional, but it is to the square of I. So a slight change in I makes greater change in H. As I mentioned before, it may be to the lowest value or to the highest value, but the change will be obvious and it will be more than that when R and T changes. Okay. Now the thing is that here in table 1.3, for the first heater, resistance is high. For the second heater, resistance is low. As the resistance is low for second heater, more current will be passed through that heater. As the resistance is high for the first heater, low amount of or less amount of current will be passed through the first heater. As the current value is more for, or the value of current or the intensity of current is more for the second heater, according to our equation H is equal to I square RT, more heat will be generated in the second heater. That is the case here. Okay. Should keep in your mind, for these two heaters, the voltage remain the same. And if it is the case, if voltage remains the same, you can consider them as two heaters connected in parallel. And in such a case, as I mentioned before, while we were discussing an experiment given in page number 11, I told you if two resistors are kept in parallel, the one with the low resistance value produces more heat. This is due to the fact that for them voltage remains the same and I value will be more for the one with low resistance. As the resistance is low, more I will be produced there, and that is why in that case more heat energy will be produced. Okay, as the resistance is low, more current will be passed to such resistors, and that is why H will be also more. I think it is clear for you. So for this question, the only answer you have to write is intensity of electric current is I. Intensity of electric current is high. Now second question. In which way does the change in resistance influences the heat developed? As the resistance increases, heat decreases. As resistance increases, heat decreases. For someone, this might be a confusion, because in the equation H is equal to I square RT. If R increases, then H also increases. But here the case is very specific. You have two heaters which are working under the same voltage and which work for the same time. And considering both of them have same voltage, we can say that they may be like two resistors connected in parallel, because in parallel circuit voltage remain the same. And in such a case, the one with higher resistance only allows low amount of current to pass through that, and the one with lower resistance allows high amount of current to pass through that. And we know that if the current value changes and if it is high, the heat energy produced will be also high, and the change is more pronounced than change in R and change in T. If it is not clear for you, you may ask. Okay, you may ask, I will repeat again, but you should make this clear because it is a concept. Now the next question is, find out the current in the heaters A and B and compare the heat developed. I told you it is obvious that the one with the low resistance will be having more current passing through it, and the one which is having higher resistance will have low amount of current passing through it. Let us check How we will be able to check? We can use the equation Ohm's law, where we can write V is equal to IR or I is equal to V by R. In the case of heater A, I will be equal to 230 by 1150. For the second heater, I will be equal to 230 by 460. And obviously, numerator remain the same. Here the denominator is larger and here the denominator is lower. So for which one I will be greater? For the second one, I will be more than the first one. Okay, second one, I will be more than the first one. That is, as the I value for the second heater is more heat energy is produced there. The correct answer is for second one the I value is 0.5 ampere. For first one it is 0.2 ampere. From this it is obvious that as the I value is more for the second heater, more heat will be produced there. Okay. So I think it is clear by now. Now what else in that question? How do the resistors bring about a change in current in the circuit? So how they bring out change in current? The change in current is brought or bring about by the change in resistance. Consider two resistors as I mentioned you. If some amount of current reaches this junction, what the current first analyze is the value of resistance in both these cases. Wherever the resistance is low, maximum amount of current will flow through that. The remaining current, maybe very low amount, it will be passing through the other resistor. If both of the resistors are having same value, 1 ohm and 1 ohm, just an example, then same amount of current will be passing through each of these resistors. It will be divided equally. If 10 ampere current reaches here and both of these resistors are having same value, 5 ampere flows through here and 5 ampere flows through this resistor. Suppose the resistance value is more, one will be 100 ohm and other is just 1 ohm. The maximum amount of current will be passing through this low resistance, and inside the higher or through the high resistor we can see very low amount of current passing through. Okay, now we have many more questions to be discussed from in-text question that will be continuing in next class. If you have any doubt, you can ask it. Okay, thank you. We'll see you next class.